this video, we're going to go over the endocrine system. So make sure you have your packet ready to go. And as always, make sure you are not only labeling the anatomy, but taking notes on the physiology. So as I go, for each comment I make, I'll make a little star there so that you know there is some type of physiology you should be taking notes on. And if there's comments I make and I don't have a star, but you still think it's worthy of note-taking, then that's excellent. You should be doing that as well. On this first page, we're looking at just the overview, so we're just going to label the organs associated with the endocrine system. Because we're going to move on to each of these organs individually, I'm not going to have any physiological comments to make on this page. This will strictly be anatomy. So to start off, A, we're looking at the pineal gland. Followed by our pituitary gland. So both of these are within the brain. We then have our thyroid in our throat. What's not pictured here is the parathyroid because that's on the back of the thyroid. We'll get to that when we get to the thyroid page. D, we have our adrenal glands. E is our pancreas. And then the sex organs being the ovaries and testes, or testis if you're just talking about one. Okay, so let's go ahead and talk about these in a little more detail. So our next page is organs of the head. Okay, more anterior, we have the pituitary gland. And more posterior, we have the pineal gland. So, most of the physiology on this page is going to be related to the pituitary gland. However, I'd wanted to talk to you real quick about something interesting I read about the pineal gland. The pineal gland actually influences melanin production or melanocyte activity, which we talked about our melanocytes in the integument system. Apparently, because of its association with vision, when your eyes are exposed to UV radiation, it kind of tells the pineal gland that you need to activate your melanocytes to produce that melanin and protect your skin from radiation. However, if you wear sunglasses, you're more likely to inhibit that pineal gland function because your sunglasses are helping block that UV radiation, and you're more likely to experience skin damage or sunburn. So, just a little fun fact there. Let's go ahead and focus on this middle diagram in a little more detail. So we have the pineal gland here, which is more posterior. But what I really want to talk about, or what this diagram really is talking about, is the supporting structures of the pituitary gland. The pituitary gland is connected to, and this isn't labeled here, this is the hypothalamus right here. It's connected to the hypothalamus through a stalk called the infundibulum. So that infundibulum is kind of like the connection or the supporting stalk of the pituitary gland. And you can see that the pituitary gland right here, I'm going to outline this, has two lobes. The back lobe, I'm going to tell you the anatomical term, but then I'm also going to tell you the term we're actually going to call it. So it's technically called the neurohypophysis. However, in most readings, and even when we're talking about hormones in various texts that you're going to come across, they're going to refer to this as the posterior pituitary, and that is perfectly acceptable. So this is the posterior pituitary. Every once in a while you'll hear somebody shorten it to the post-pit. That's fine too. And then the anterior portion is the adenohypophysis, but we're going to refer to it as the anterior pituitary. Okay. Now, our pituitary is housed within the sphenoid bone of the skull. We're going to talk a whole lot more about that when we go over the skeletal unit. But this bone actually has a nice groove in it called the hypophyseal fossa. So we called these the hypophysis, like the adenohypophysis. This is the hypophyseal fossa. And fossa is another word that means groove or depression. You're going to hear this term a lot when we go over the skeletal unit. And then finally, just to give you a reference of where we're at, this is the corpus callosum. If you have taken psychology, you've probably been introduced to this before. The corpus callosum is the connection between the left and right lobes of your brain. And you can see, so here's this structure here. This top is giving you a reference of where we're at. So we're very central in the brain right now. Final thing here, we are going to compare the histology of our anterior pituitary and posterior. It's important to know that we have acetophilic and basophilic cells. These are mentioned because these cells are going to make hormones. Okay, the anterior pituitary is able to make its own hormones. However, the posterior pituitary does not. Instead, what happens is the posterior pituitary is going to store hormones that are produced in the hypothalamus. In the hypothalamus, I highlighted up here earlier. So as you can see, this infundibulum, this stalk, is going to kind of be a connection between the hypothalamus and the posterior pituitary. So that way the post-pit is able to store the hormones that are produced there. All right, let's go ahead and talk about some of the posterior and anterior pituitary hormones that are produced. I'm going to go ahead and label them. However, I expect that you will be researching these hormones in a assignment that is to follow this. So we're not going to focus really on physiology so much on this page. One thing to know, though, is the endocrine system is a system that relies on chain reactions. So when a hormone is triggered, it's most likely that its function is to trigger the activity of another hormone, which then will act upon another hormone. So it's almost like a domino effect. And for quite a few, the majority of our anterior and posterior pituitary hormones, once they are released from the pituitary gland, they are not going to be involved in direct action, but instead they are going to trigger additional glands throughout the body, which then are going to continue on with the overall function that's occurring. The other thing I like about these diagrams here, aside from the fact that they show you what organ is being acted upon, is that we can actually divide this into an anterior, posterior, pituitary. So on one side, we're just looking at hormones from the post pit. On the opposite side, we're looking at hormones from the anterior pituitary. Okay, so let's go ahead and focus on the male that's at the top of the page. Seeing as he's looking to his left-hand side, A is going to represent our anterior pituitary. Whereas H is going to represent our post-pit. And let's go ahead and cover all our anterior pituitary first, and then we'll come back to our posterior pituitary. So first off, we've got B. We are looking at the release of thyroid stimulating hormone. And you're going to be doing a little more research on this on a following assignment. The other thing that we're looking at here, we are going to be playing a role on your bones, is growth hormone. We've got another hormone here that's going to trigger responses in the adrenal glands. This is adrenocorticotropic hormone. And then finally, we have two hormones that are functioning in the testes, one being follicle stimulating hormone. That was messy. Let me fix that. And then we have luteinizing hormone. And then regarding the posterior pituitary, we're going to have action on the kidneys via antidiuretic hormone. And then antidiuretics, there's quite a few different things that could act as antidiuretics. We're specifically talking about vasopressin. Okay. That covers a few examples for the male. Let's go ahead and look at the female. She's looking to her right-hand side, so we're going to swap which side we're looking at, anterior versus posterior. So we have our anterior on this side, and our posterior pituitary on our right hand side. And again, regarding the anterior pituitary, we're going to have the same hormones here. So we still have thyroid stimulating hormone. You know what, I'm just going to, whoops. Thyroid stimulating hormone. Okay. However, we also now have what's called prolactin. Okay. Lactin, similar to lactose, which is a milk sugar, pro being positive, encouraging. So prolactin is going to encourage milk. You'll get more into that when you do your hormone research. It's just that prolactin is obviously not present in the male. It's present in the female. But we still have the remainder of these hormones that are staying the same, which is growth hormone, and adrenocorticotropic hormone, follicle stimulating hormone, oops, I'm sorry, switch, follicle stimulating hormone is G, and luteinizing hormone, which is F. And then if we look at posterior pituitary, we still have vasopressin to focus on the kidneys, but we have a new hormone which you may have heard of called oxytocin, which is going to function on the lacteals or lactation ducts, as well as the cervix of the female. And that covers hormones with the pituitary gland. Let's go ahead and jump to the thyroid. So first off, if we look at structure, this whole gland here that's represented by A is the thyroid. It is a butterfly shaped. It has two lobes. Thankfully, they're named pretty simply. We just have the right lobe and the left lobe. And these are going to be connected by what we call the isthmus. I know it's a awkward word to say. Okay, and the isthmus is going to be our connection between our lobes. You've probably had your thyroid checked, whether you realized or not. This is when your doctor is doing a physical and they feel on your neck, they feel both sides, and they kind of push around. They're trying to see if you have any inflammation of your thyroid gland there. Now, there's quite a few different histology notes down here at the bottom. If you look at E, we're looking at the colloid. And the colloids are essentially open areas where thyroid hormones are going to be stored. Those thyroid hormones are going to be produced and secreted by our follicular cells. Okay, so those follicular cells are going to produce those thyroid hormones. And then G, which is off to the side, is our parafollicular cells. Now, para, which means near, the near follicular cells in humans, the function there isn't as understood. We know that in some different species, like rodent species, the parafollicular cells are involved in calcium levels or monitoring calcium levels in the body. As for us, it's not as, I suppose, defined as it is in other species. As I mentioned earlier when we did the overview, the thyroid actually has 4 glands attached to the back of it as well. So here we're looking at the posterior side of our thyroid, which is A. And we have these 4 small glands represented by B. These are going to be our parathyroid glands. And the parathyroid glands have different types of cells, one being principal cells. These may also be referred to as chief cells. And oxyphilic cells. Now, the function of oxyphilic cells are not super defined. However, we know that our principal or chief cells are going to secrete what's called parathyroid hormone. And again, with your upcoming assignment, you will get a little more information about that. If we move on to the next diagram, we have our pancreas here. And we've got 2 different histology-related notes to make, or structures, I should say. B, this large section here, is called a pancreatic islet. And pancreatic islets have quite a few functions here. We're looking at the secretion of insulin, of glucagon, and somatostatin. But it's important to note the pancreatic islets are going to secrete via endocrine function. So if you think back to our glands from the epithelial section of our diagrams in the tissues unit, endocrine meaning that it's secreting in between the cells. I note this because the second type of structure here in our pancreas is an acinar cell. And the secretions of our acinar cells are actually going to be exocrine, which means that instead of being secreted in between cells, the secretions are going into a duct. And then just to give you a reference of where the pancreas is located, we have this diagram here at the bottom. So you can kind of see the stomach is resting on top of it, and the head of the pancreas is kind of nestled in with the top part of our small intestine, which is called the duodenum. Let's move on to our adrenal glands. Adrenal glands rest on top of our kidneys, so we have 2 of them. And if you were to take a cross section of the adrenal gland, this This isn't outlined very well. This is more like this. You have two sections here, one being the cortex and the other being the medulla. The medulla is the more central tissue of the adrenal gland. And if we move down to the bottom here, we have this histology portion. I'm going to work our way up. If we start in with the center of the medulla, we then have 3 layers that make up the cortex, each of which have their own functions. The innermost layer is the zona reticularis, which is then followed by the zona fasciculata, and finally the zona glomerulosa. Now what I would like you to do, instead of me going over each layer, I would like for you to utilize this reading here. By the way, if you haven't been using these, I highly recommend you do. They're great little summaries that go along with these diagrams. Using this reading, I want you to go through and pull out the functions of each of these zonas that make up the cortex. Okay. And that will be your physiological notes. And then finally, our outermost membrane of our adrenal gland is the capsule. It's kind of like the encasement layer. Almost done here. We just have our last diagram, which is the gonads. We're going to talk about both ovaries as well as the testes. So let's go ahead and start with the females. We're looking at an ovary here. And this diagram here, we have a nice cross section where we've been cut in half. And there's quite a bit going on here. First off, these right here are the ovas, or the eggs. And what happens as the female goes through her cycle, one of these is going to begin to mature before being released. As it's being matured, we have these granulosa cells that are going to surround the ova that is being prepared for release. And we're also going to have these follicles in the surrounding area as well, called ovarian follicles. And what happens is we're going to have estradiol and progesterone produced by these cells and released at these follicles to help prepare that egg. And then once that egg is ready, we are going to have an exocytosis of the follicle. So the follicle is going to essentially rupture and release that egg into the fallopian tube. That's why, unfortunately, menstruation can be painful, because you have this rupturing occurring to release the egg. And then finally, we have another section this area called the corpus luteum. And this is also going to produce progesterone. Progesterone being sometimes what's called the pregnancy hormone. You will focus more on that when you complete your research. And then let's go ahead and talk about the males. With the testes here, we're just looking at one testy, or a testis. And the testis is going to produce sperm via exocrine function. So exocrine function meaning that the sperm is going to be released into ducts, and those ducts are called seminiferous tubules. And then finally, in addition to the seminiferous tubules, we have cells that are referred to as our the male's interstitial cells. And these interstitial cells are going to have an endocrine function in which testosterone is released. All right, so that covers the endocrine glands, and coming up shortly, you'll have the opportunity to look more into the various functions of all the hormones that were mentioned within this video.